Hi everyone, it's Miss Parlavecchio here, and I'm going to be teaching a review on adding and subtracting polynomials. Before we begin adding in this first example, I just want to remind you all of standard form in the final answer. Standard form is when we take the term with the highest degree and put that first, and then the term with the next highest degree goes second, so on and so forth. So we're writing it in descending order from the highest exponent down to the smallest. Degree in polynomials refers to the exponent of the highest value, so that's how I start by determining what common terms can I add or subtract together. In this example, to go forward with adding, I notice that 5b squared is the highest degree in the first set, and 3b squared, also a squared value, is the highest value in the second set. So I want to go ahead and add them together. What we do is we see positive 5b squared plus a positive 3b squared, and we're just going to add the coefficients of 5 plus 3, which is 8, and keep b squared as it is. Do not add the exponents. We only add exponents in a multiplication sentence. Then I'm going to cross it off since I know that we combine those like terms and move on to the next highest value of exponents. And I see in the first term it's 6b, and in the second term there's also an 8b. Both have a b with an exponent of 1, so I want to add them together, and I have 6b plus 8b, which is going to be plus 14b, and then I cross them off. The last term we're left with in both is a constant, and we have positive 3 plus a negative 2, which is positive 1, and I can cross them off. We've combined all of the like terms, and this is our most simplified answer written out in standard form. Please do not combine terms that do not have the same variable and same exponent. So 8b squared plus 14b cannot be combined. They stay separate. Another example is subtraction. Now, with subtraction, there is an extra step that I like to start out with, and that is distributing the subtraction symbol by multiplying by -1. The reason for that is we are subtracting every term in the second polynomial from the first one. So instead of just going right ahead and trying to do mental math, I like to rewrite what the distributive property of -1 would show. So if I do -1 times -3n to the third, it's now positive 3n to the third. And then if I distribute the negative sign to the middle term, it's -1 times -6n squared, or now positive 6n squared. And then -1 times -1 times positive 8n is going to give us a -8n. So everything just switches its signs. And then we're going to combine the first polynomial with this new sentence in red. Look for the highest degree. I see that's positive 6n to the third, and there's also an n to the third in the second. So we have positive 6n to the third plus 3n to the third, which is 9n to the third. Then the next highest degree would be n squared. So I have a positive 4n squared plus a positive 6n squared, which leads us to positive 10n squared. And then the last terms that we are left with is just n, and that is positive 5n minus 8n, or -3n. We've combined all of the like terms. We have it in standard form, so that means we are done simplifying. I hope this video helps refresh your memory a little bit on how we first learned adding and subtracting polynomials, and I wish you the best of luck with the classwork that will soon follow.